My talk LGCW was around how we can maximize cancer treatments and research through sort of omics data, data sharing, and open science. I wanted to raise the value really that data archiving has for omics research, and then talk about how that might work back to actually benefit patients. So data sharing brings a number of benefits. On the research side, it means that there's more data available. And of course, with more data available, that means we can do more research. And then there's the greater opportunities to bring benefits back to the patients. If you're working with particularly rare cancers, data sharing via archives is really beneficial because it allows you to create cohorts that may not exist in your local population. So if you're only seeing a couple of cases of a particular cancer type in a year, it may be that by going to data archives and looking at the data that's been deposited by a number of other researchers, you're much more able to actually create a cohort that can be used for your study. There's also the benefit that it helps make our results more transparent. So when we are publishing papers and trying to demonstrate the value of our findings, having the data available so that other people can challenge our findings, they can reperform the analysis, is really beneficial when we think about research transparency. There are also a number of practical benefits. So omics data tend to be large. A BAM file, which is one way of storing a whole genome sequence, would typically be somewhere in 140 to 170 gigabytes. FastQs, which is a different way of processing the data, you would look to maybe 30 to 40 gigabytes. And as you can imagine, if you're having 1,000 patients with a whole genome sequence, suddenly there's quite a large technical and resource overhead to storing that data. Increasingly, we see data archives as well offering analysis services to researchers. So not just a place where data is being stored, but also offering platforms through which you can actually perform the analysis on the data without having to download it. So these would be sort of secure sort of data processing environments where researchers can go in, they can analyze the data, and then they can get their results out of it without having to worry about storing the data locally or the overhead of downloading large amounts of data. There's also value that data archives are typically funded for longer than the average research project. So research projects may be funded for sort of 5-10 years would be usual, but data archives offer that much more long-term solution. So there was a research performed by Atwood et al. In 2015, looking back at key sources of biomedical data from the late 90s. And over 60% of those in that 18-year period were no longer available. And so that research data effectively had been lost. We also see that there's little long-term consistency in sort of storage of data or just through project websites. And so what may happen is that in the future, data that was available and was used for research is suddenly no longer available simply because the projects are no longer able to keep their website up because the funding's run out, or it's on an institutional website and that has changed and suddenly the data are no longer findable in an easy way. That's not to say that data archiving isn't without challenges. One of them is around achieving the idea of fair data, but when we're working with sensitive data. So fair means that the data are findable, accessible, interoperable, and reusable. And of course, when you're thinking about findability, you're thinking about things like metadata. So how do we describe the data such that it can be found easily? When you're working with sensitive data, though, you want to make sure that the data are findable. So we want to describe the data as well as we can. But at the same time, we don't want to be describing it such that we can re-identify the data subjects. So when we're thinking about sort of genomic data, we may wish to include phenotypic information as metadata so that researchers can understand what it is that's likely to be in this genome data before they access it. But of course, for very rare phenotypes or unusual combinations of demographic variables, that could potentially lead to re-identification of those data subjects. And so we have to balance that. There's also issues around how do we govern access to the data. So who is it that approves applications, particularly as we think about sensitive data? How do we avoid the siloing of data? So there are an increasing number of data archives available. And although there are standards around how those data archives operate that researchers can consider before depositing their data, there is a risk that if we have too many or data archives which aren't set up to be interoperable, that effectively we end up with data trapped in lots of small little archives, and therefore it becomes harder to use it in an interoperable way. And finally, there's always the fact that we're dealing with data that belongs to patients and the public more broadly. And we want to make sure that when we are archiving it and storing it and then making it available, often this is done without them knowing that it's being used. Obviously, they probably have consented to it being used for research use, but they may not be aware of every specific project. We want to make sure that they're supportive of what we're trying to achieve. And this comes about through engagement, about listening to what their concerns might be, but providing information about what we're doing in a way which is understandable to the population as a whole. And what we want to try and do is foster an environment and a kind of societal attitude which is both pro-research in that it supports laws and funding that enable research, but also a sort of pro data sharing, because it's really the lifeblood of research. So data archiving at the moment, it is often done in the sort of higher income countries, and that's because of the cost of resourcing. But that's not to say that we don't see some really incredible work coming from lower and middle income countries. We can look at something like the H3 Africa Genome Project, which is working across Africa and bringing together researchers to produce and support projects which are archiving genomic data, collecting genomic data, and doing some really incredible work around public engagement. I was recently in attendance at the Global Alliance for Genomics and Health, GA4GH conference, and there was a terrific presentation about the way in which COVID had stimulated the collection and sort of archival of genomic data in Indonesia. And so I think there is real value for researchers and institutions in middle and lower income countries to engage with groups such as GA4GH and the Research Data Alliance, who are working on standards and policies and some of the practical information about how you set up an archive and how you manage an archive, and some of the technical standards that you should try and adhere to, as really great sources of information and support. One of the benefits as well is that increasingly we are moving into a sort of cloud computing world, if not there already. And the value there is, cloud means someone else's computer. And so whilst there may be high resource costs in terms of setting up infrastructure, particularly in the genomics world, because the data are so large, and you very quickly need a lot of storage and a lot of compute power, that there may be opportunities there to have researchers in sort of lower and middle income countries to access data through cloud resources. And so the resources could effectively be hosted anywhere in the world, and you're only accessing them as and when you need them. So you haven't got the same kind of overhead. It could be a case, for example, that you have an institution that's in a higher income country that's storing the data on behalf of researchers working in a lower or middle income country, and then providing access to that data via a cloud-based sort of research environment. I think one of the challenges in those sorts of scenarios is that we want to make sure that researchers in those countries are not being locked out of the research and that the data that they are producing. There's an idea around research equity, which is really important. And what that means is that we shouldn't just see researchers in those countries as collecting data on behalf of researchers working in wealthier countries, but actually there's a huge amount of potential and research capability globally. And by making sure that researchers in those countries have access to the right sorts of resources, we can really bring that potential to the fore and see some really amazing work. I think in terms of going forward, we see, although the technical solutions are enabling data sharing, perhaps in a way we've never seen before, we do see increasing the focus around data sovereignty. And to a certain extent, that is understandable when we look at the way that certain groups have been sort of excluded from the research world and data taken and used in a way which doesn't benefit the population from which it was taken. You can understand that there may be a reluctance to share. And as we see an increasing interest and increasing demand for data protection legislation globally, that obviously impacts our ability to do research and to share data. And so I think what really will need to happen is much more around the political will to ensure that data is being shared and shared effectively. As we know, cancer doesn't stick to national borders, and particularly again with rare cancers, if you only have 1 or 2 cases in your country, that's not enough really to be doing a great deal of research. And so you need to be able to take data in from other countries and build your cohorts so that you can really investigate the issues. And that will come back to sort of political will really to enable that data sharing. I think the technology is quite capable in most circumstances. Of course, it somewhat depends on the quality of your internet connections and networking resources and things like that. And we've seen with COVID as well that having researchers all around the world able to quickly perform analyses and share the data and share the results is hugely beneficial in an interconnected world. We can't wait for for a pandemic to reach a country which is slightly wealthier that can perhaps perform the research. We need to make sure that we have really talented researchers all around the world who have resources available such that they can perform their research and share those results. I think as well as we go forward, the role of data archives will increase, and hopefully that will help patients so that we can really sort of have lots of data available so that we can speed up the rate at which we're finding more information about cancers and finding treatments. That the researchers themselves can really focus on doing the research and not having to worry about some of the issues that they currently do around the data storage and what happens to the data and data management. And what I'd like to see is that we have a greater feedback mechanism for patients. So if you are a patient and unfortunately you haven't been able to get a diagnosis at this time, but perhaps by sharing your genome into a research archive, you may find that someone uses that data, they perform some analysis and they find something which could actually be beneficial to your treatment. And what's crucial, I think, as we go forward is how we work out how we can deliver those results back to the patient and back to their care teams in a timely manner and a safe manner as well from a data protection perspective, so that we can almost use it as a way of crowdsourcing care and sort of the understanding of disease and illness.